Amazing. Okay, so hello everyone. I'm Bartek. I was speaking 2 days ago, and the one feedback I got is that I'm speaking too fast and there is too much content. This is worse, so stay tuned. I mean, hopefully not. I really try to limit the number of slides. So today I want to really talk about, our experience using Prometheus on Google Cloud, especially in the product I maintain. But essentially, it's the time to kind of like inspire each other, celebrate what really worked well in Prometheus and what we could innovate on from the time on. So yeah, I work on Google Cloud Managed Service for Prometheus, and in this context, I'm talking about the collection side of things, where we are running Prometheus servers actually as daemon set with our custom Prometheus operator, which is open source. You can kind of like deploy manifest on any Kubernetes cluster. It just works, and I'm really impressed that this is working so well, and I couldn't recommend this architecture more, the daemon set architecture. And we solved kind of many limitations, and let's share what we learned so far. Yeah, first of all, it was super useful to keep things simple. Like, it was a difficult decision: should we support Prometheus operator CRDs or create our own? And we had to kind of create our own because we cannot support service monitors in architecture where we have daemon sets, and this is due to Kubernetes API scalability. So we only have pod monitorings, but in turn, that works just fine and it's good enough for majority of use cases. So yeah, it's actually we are able to simplify the configuration, no relabeling before metric scraping, but there is some kind of our own simpler kind of relabeling configuration for adding and removing labels. There is some other relabeling after. So anyway, we were able to simplify, so on scale we had less issues, and yeah, it's sometimes good to do. Then of course efficiency is super important. Obviously on such a scale, and I forgot to mention, but we have literally millions Prometheus instances running on production, and trillions of samples per day. And in this case, if we save hundreds of megabytes of memory, that's hundreds of terabytes, right? So literally it's super important. That's why we run servers which are very fine-tuned with those dangerous flags like block durations set to 10 minutes and the retention to 30 minutes. We are kind of playing with agent mode, but we're not super decided yet. But I would like to inspire us to really thought about something more innovative, like maybe pass-through mode, which is, well, kind of removing the durability of wall and not having a wall and simply focusing on sending. And this is what we use. We don't have HA because we cannot afford adding yet another, potentially 1 gigabyte of memory for those millions of instances. So we just have a very fast instant startup because we don't have persistence. We don't need to wait for replies. So the moment Prometheus is down and up, it's literally between scrapes or maybe missing one scrape, so it's totally fine. So generally, in practice, that model works pretty well. So I encourage you to try and not always be forced to persist every single sample. We have counters for a reason. So anyway, this is what our experience so far. And I would love to experiment with Prometheus to have the super fast mode without persistence. And then of course we are working on PromBench, our benchmarking tool, to include remote write or those export agent mode benchmarks. Then of course, out of memory and VPAs. So VPA is amazing and it's needed because, as we said, some nodes have bigger amount of targets and some nodes not. We are working with Kubernetes to kind of improve VPAs in general for daemon sets. It was pretty bad, but now the changing limits is actually not restarting container, which is amazing. And then the second thing is that we are kind of trying to propose daemon sets being able to have different memory limits per different agent, per different node, which would be amazing. And I would like to inspire you to think, and together the community, about some remediation. So OTLP has already a memory limiter processor, which essentially kills certain OTLP pushes if there is threshold of memory hit. And in Prometheus, we don't have anything like that. And it would be amazing to really, experiment with something that disables certain targets if you have too many targets for the certain collector, right? It's better than crashing the whole collector. So that would be amazing. Let's innovate here. And finally, we are working with Prometheus as well. We already have that in our fork. Scalable secrets. At the end, you cannot, as a demon said, you cannot pull all the secrets from 1,000 nodes, and every single node would have access to all the secrets to every application. So there are remote secrets coming, and it's as easy as referencing a secret from your secret provider, for example, Kubernetes API directly. So that's kind of solves this. So it's in progress. We're working on it. And then Remote Write 2.0 and OTLP, we need structure exports for efficiency and integrating with OTLP. So that's kind of like what's kind of like on the table right now, important to add. And we are working to actually add OTLP export to Prometheus for those reasons. So to sum up, let's not talk about that. I want to just thank the community. Like all of this, those millions of Prometheus instances on scale with so many various monitoring use cases wouldn't be possible with you, with community. So really amazing work. Yeah, Prometheus team and community. So yeah, that's it from my side. Thank you.